Welcome to MetaMinds Academy. Today in this video, we are going to learn Introduction to Partial Differential Equations. So how a partial differential equation looks like. So how do you define a partial differential equation? An equation that contains partial derivatives is called a partial differential equation. If the equation contains partial derivatives, it is partial differential equation. If the equation contains ordinary derivatives, it is called ordinary differential equation. If the equation contains both ordinary and partial derivatives, it is called mixed differential equation. We are not going to study any of those. We are going to study only partial differential equations, how to solve PDE in this series of lectures. What is an example of partial differential equation? Dou z by dou x plus dou z by dou y equal to 2z. So here z is a function of x and y. Dou z by dou x is first order derivative of z with respect to x. Dou z by dou y is first order derivative of z with respect to y. So this is an example of a partial differential equation because it contains partial derivatives. And this is also an example of a partial differential equation as it contains partial derivatives of both first order and second order. So you can have partial derivatives of any order in the equation. Partial differential equation of first order. That means our concentration is to study first order equations. So what is the general form of a first order partial differential equation? So because it is the first order, you should contain only first order partial derivatives. So what are they? They are also always denoted by P and Q. What is P? P is dou z by dou x, Q is dou z by dou y. It is a universal notation. So a first order partial differential equation may contain variables x, y, z, p and q. First order derivatives p and q. So this is the general form of a first order partial differential equation. Now coming to the solution of the equation 1. So first order partial differential equation, any function of the form x, y, z, a, b. X, y, z, a, b. See, you cannot find p and q here. Here p and q here. Derivatives are there. It is differential equation. Now there are no derivatives in this, right? X, y, z, a, b. A and b are arbitrary constants. So any function of this form which satisfies the given equation, partial differential equation of first order, is called a complete solution. Is called a complete solution or complete integral. It is also known as complete integral. And what is a general solution? The general solution of a partial differential equation is any function of two functions again like u comma v, capital F of u comma v equal to 0. What are u and v here? U is a function of x, y, z, v is a function of x, y, z. That means if you can write v as equal to g of u, this is also possible. Right? So you have a relation between u and v. You have a relation between u and v which satisfies the given partial differential equation. Right? If you can find such a u and v, then this function or this equation is the solution of or general solution of the given first order partial differential equation. Okay. Now let us see what is a linear partial differential equation, quasi-linear partial differential equation, and when do you call the equation as a non-linear partial differential equation. So coming to linear partial differential equation, a PDE is said to be a linear partial differential equation if the dependent variable z and its derivatives are of degree 1 and products of z and its derivatives do not appear in the equation. So what is dependent variable? See, z is a function of x and y. X comma y are independent variables. Z is the dependent variable. Z is depending on both x and y. Here the dependent variable z and its derivatives. What are its derivatives? Dou z by dou x, dou z by dou y, dou square z by dou x square, dou square z by dou y square, and so on. You can have first order derivatives or second order or third order, any other derivatives, right? So these are all derivatives of the dependent variable z. So what should happen? The dependent variable z and its derivatives, right, are of degree 1. Their degree should be 1 in the equation. And what is the another condition? And products of z and its derivatives do not appear in the equation. So degree 1 means what? We have the power should be 1. So in the equation, if any of these derivatives present, then the degrees must be 1. And what is the other condition? You should not have products like z into dou z by dou x. Right? What happens? Here the degree of z is 1, degree of dou z by dou x is 1. Because of the product, the degree of the term becomes 2, 1 plus 1. Right? If you write one more derivative like dou z by dou y, right, z into dou z by dou x into dou z by dou y, then you have 3 dependent variables in the product, so the degree becomes 3. If you have addition or subtraction in between, then you have 3 terms and each term has degree 1. Right? So the second condition is there should not be products of the dependent variable and its derivatives in the equation. In that case, we call it as a linear partial differential equation. See, here x is independent variable, y is also independent variable. So we should not consider, it is not mentioned in the definition to consider the independent variables. Right? Our concentration is on dependent variable and dependent variable and its derivatives. Okay, that means z dou z by dou x and all, not of x and y. So you can have products with independent variables. You can have products with independent variables x square, y square. So even though you have product, it doesn't matter. Still it is considered to be linear. Here you have x square into p. What is p? P is dou z by dou x. We call dou z by dou x as p, dou z by dou y as q. So therefore it is x square into dou z by dou x plus y square into dou z by dou y equal to z. So here the degree of z is 1, degree of q is 1, degree of p is 1. Right? So here the degree of this entire term x square into p is also considered to be 1. That means we neglect x square degree, x degree. Okay. So that is how this is considered to be a linear partial differential equation. But here, coming to here, this is not a linear partial differential equation because you have the product of z and p. What is p? Dou z by dou x. So product of z and p, z is a dependent variable and p is its derivative dou z by dou x. So it's like z into dou z by dou x. Right? So you have product of the dependent variable and its derivative. So this is not a linear equation. Coming to this, p into tan x plus q into tan y equal to tan z. So is this a linear equation or non-linear equation? So here you see the degree of z coming to tan z. What is tan z? Tan z is actually a non-linear function. Tan z is actually a non-linear function. If you have only z here, then this becomes a linear equation because the degree of p is 1, degree of q is 1, but degree of z is not 1 here. You have tan z. Tan z is sin z by cos z, and you know the expansions of sin z and cos z, and you can also write the expansion of tan z. You will have non-linear terms in the expansion, right? So tan z is non-linear. So degree of z is not 1 here. So it is a non-linear equation. Coming to this, so here it is not about the order of the derivative, it is about the degree of the derivative or degree of the dependent variable and its derivatives. See, here the order of the derivative is 2, but degree is 1. Though it is a second order derivative of z, it is a derivative of the dependent variable, but its degree is 1. So here also degree of z is 1. So it is considered to be a linear partial differential equation, though you have second order partial derivatives in the equation. Now coming to quasi-linear equation, partial differential equation is said to be quasi-linear if the degree of highest order derivative is 1, degree of highest order derivative is 1, and no products of partial derivatives of the highest order derivative are present in the equation. See, here coming to this equation, you have a product of z and dou square z by dou x square. So what is degree of z? 1. Degree of dou square z by dou x square? 1. Now what is the degree of dou z by dou y? This is the derivative of the dependent variable, right? Q. So the degree is 2. Though the degree is 2 of the partial derivative dou z by dou y, this is called a quasi-linear equation. That means it is not completely linear and it is not considered to be non-linear equation. This is a non-linear equation, a kind of, you see, it's somewhere between linear equation and a non-linear equation. We give some relaxation, and that is called quasi-linear equation, right? So that means what here? We have degree of highest order derivative. What is the highest order derivative? This is first order derivative. This is second order derivative dou square z by dou x square. The highest order derivative is dou square z by dou x square, and its degree is 1. Right? If degree of highest order derivative is 1 and no products of partial derivatives of the highest order derivative are present, right? Though you do not find any products of highest order derivatives, right? Highest order derivative products are not present, like dou square z by dou x square into dou square z by dou y square. That kind of products of highest order derivatives are not present in this equation. Therefore, this is considered to be a quasi-linear partial differential equation of second order. That means you are allowed to have degree more than 1 for lower order derivatives. Then, what is a non-linear partial differential equation? Even this is also a non-linear differential equation, non-linear PDE. Any differential equation which is not linear differential equation, which is not linear, is called a non-linear partial differential equation. Even quasi-linear is also a non-linear, right? Because it is not linear, then it is non-linear. See, dou square u by dou x square whole square. So, here you see dou square z by dou x square whole power 1. So here the degree is 2. Here the degree is 2. And you have a product of dependent variable and its derivative. So the two rules of linear differential equation, partial differential equation are violated here. So it is, at least one rule is violated. It is a non-linear partial differential equation. So this is known as non-linear partial differential equation. Okay. Now coming to the general form of a partial differential equation, linear partial differential equation of first order is of this form: p of xyz into p. That means any function of xyz multiplied by dou z by dou x plus some function of xyz q into dou z by dou y equal to function of xyz. So this type of equation, if the equation in this form, it is general form of a quasi-linear partial differential equation. So this is the most general form of quasi-linear. That means it is also semi-linear, like a quasi-linear partial differential equation. See, the functions p, q, r are involving x, y, z. That means they may involve the two independent variables and as well as the dependent variable z also may be there in the functions p, q, r. Whereas this equation is known as Lagrange's linear equation. The quasi-linear equation is known as Lagrange's linear equation. Whereas if you see the equation here, p of x, y, z is actually not containing z, right? P of x, y. That means the functions p and q, the functions p and q are independent of z. That means, see, z is not there in these two functions, right? So the multiple of dou z by dou x, multiple of dou z by dou y should not contain z. That is the condition. And right hand side also can be written as r of xyz can be written as a function of xy multiplied by z plus function of x and y. So that means the RHS r of xy is written as a linear function in z. Linear in z, need not be in x and y, right? Because we always consider the linearity, check linearity for dependent variable, right? Therefore, linear function in z is like az plus b, right? So right hand side is linear, left hand side p and q do not contain z, then it is completely general form of a linear first order partial differential equation. This is the most general form of a linear partial differential equation of first order. Okay. And in the next video onwards, we will solve the partial differential equations using different type of methods. Thank you.